to another episode of PEEPanEIP, an EIP dedicated series where we discuss an Ethereum improvement proposal and understand how it is going to make Ethereum even better. My name is Pooja Ranjan and I'm your host for today's episode on base fee opcode. EIP-3198 base fee opcode is a standard track core proposal. Created in January 2021, it is currently in review status. According to the EIP, this proposal adds an opcode that gives the EVM access to block space fee. This proposal is authored by Vitalik Buterin, Abdel Hamid Bakhtan. This is a companion proposal to EIP 1559 fee market changes, and that's why also expected in London soon. To talk about the proposal, we have Ratan Rai Sur, also known as Rai, from the Consensus Quorum Besu team. Welcome to the show, Ratan. You have joined us for the first time as a guest. So for our audience, if you could please introduce yourself and tell us a little bit more how you got engaged with Ethereum.
Sure. So like Pooja said, my name is Rai. I work on the Hyperledger Besu Ethereum client, currently employed by Consensus. And I got interested in Ethereum basically when I was traveling in 2018. I was living in Brazil, learning Portuguese, hanging out on the beach, and I had nothing better to do really. And I discovered this thing called Ethereum, and I started reading about it, and it just made a lot of sense why a system like this should exist. And so when I got back to New York, I just started teaching myself blockchain concepts, implementing like some toy protocols myself and implementing papers, and then applied to Consensus. Okay, so EIP-3198 base fee. This is a simple proposal, and it requires 1559. So there's some background for 1559 that I think is valuable to go into. So let me swap over there real quick. The main thing, let's see. Here we go. Yeah, there's a base fee. So basically, the main thing that is applicable to the base fee opcode is the base fee network-wide parameter in 1559. So as big blocks or small blocks will be added to the 1559 enabled chain, the base fee will dynamically adjust in order to increase or decrease quantity demanded for the block, for inclusion in the block, and therefore represents a kind of measure of congestion of the block. What it actually does for the protocol is that it measures how much, or it dictates how much ETH should be burned per gas. And so as you can imagine, big blocks will make that base fee higher and small blocks will make that base fee lower. And we try to stay around a target of 12.5 million gas. So because the base fee represents the kind of congestion in the network, making it observable in the EVM also gives that knowledge of congestion to contracts within contract execution. The implementation is so simple because the base fee is already known in the block header. And so there's not much to do except for just push this value of the base fee onto the stack so that subsequent opcodes can manipulate it. But it's worth going through kind of the motivation. What use cases does this enable? So this first point, contracts that need to set bounties for anyone to poke them with a transaction could set the bounty to be base fee plus X or base fee times 1 plus X. This makes the mechanism more reliable because they will always pay enough regardless of market conditions. So this kind of makes sense because if you had a bounty that was lower than the base fee, well, then why would you send a transaction in order to retrieve it? The dependency on the base fee makes sure that this is always a viable, or this always makes sense as a transaction. Gas futures can be implemented based on it. This would be more precise than gas tokens. So gas tokens is a contract that kind of represents how much state you've stored in this contract, and you get these gas tokens that represent that. And then because Ethereum has refunds, you can then later on send these gas tokens to the contract in order to free up a lot of storage and potentially essentially you have an arbitrage opportunity between times when gas prices are low and gas prices are high. The reason you can implement gas futures with the base fee is, imagine you mint these gas tokens when the base fee is low. So now the contract can keep track of at what base fee you minted these tokens. And much like futures, if you have a future that entitles you the right to buy gas of a higher value, then those will be more valuable. So if you mint gas tokens when the network is not that congested, these are not going to be as high value gas futures. But if you mint these gas tokens when the network's very expensive, then these are more valuable gas futures that you can use later on in also high base fee environments. Improve security for state channels, plasma, opti-rolls, and other fraud-proof driven solutions. Having the base fee as an input allows you to lengthen the challenge period automatically if you see that the base fee is high. So definitely
sorry
not.
To interrupt.
Yeah.
Sorry, I just wanted to clarify one thing.
Yeah.
So when
For
you're
sure,
talking about the futures with the gas, are you basically like, I mean, is it the same thing as in like going out and buying a couple barrels of gasoline, like when the price is low, and then using it like whenever it's high again, just to clarify?
Yeah, I think it's essentially that. So maybe an example, as far as I understand, right? Let's say you mint a gas future using this gas futures contract, and the base fee at the time is 200, right? So the contract kind of stores that you minted these futures with this, I don't know what they called it in the future context, but like, let's say a strike price, right? With this strike price of 200 or something. In a future contract execution, you are not going to be able to kind of redeem those gas tokens for the in a high base fee environment. So for example, your like gas tokens that were minted, your gas futures that were minted at 200, right? They're not going to be valuable if the environment the contract is executing in is a high base fee environment, because the contract won't let you take them out. So yeah, basically it kind of entitles you to be able to get your transactions in during the same kind of environment that you minted them.
And would that cause problems? I mean, because I presume that the base fee changes to limit network congestion and to like reduce the opportunity or try to discourage like overage for gas, right? So like if you were to kind of like circumvent that, would that cause problems?
I can't say for certain. I think that the kind of side effects with 1559, for me, I don't understand well enough to be able to judge those interactions. Actually, oh yeah, I should mention that Abdel is the main author on this EIP, and he was the one who implemented 1559 on Besu, and I'm just filling in for him because he's going to have a kid soon. Yeah.
That's totally fine. I guess what I'm curious about, because like, do these already exist? Like these futures?
So not futures, but these gas tokens exist, and they don't care how congested the environment is that they get minted or used. And so what happens is that you mint them because they're completely fungible, right? You mint them when the when gas is cheap, and then you spend them when gas is expensive. And I believe the efficiency gains come from the fact that now they're not completely fungible. So I think you would have to mint the gas futures, at a certain point in the same kind of congestion environment that you'll end up using it, I think.
Mm-hmm. Okay. Thank you.
I have one question related to it here. Like you mentioned that this proposal that has advantage of the base fee opcode over the gas token for looking for the gas futures. And I was also trying to understand how is base fee opcode more precise than gas token.
Okay, yeah, I think it comes mainly from the fact that gas tokens right now are fungible, and therefore there is this kind of opportunity for using them when the price is low, minting them when the price is low, and spending them when the price is high. whereas gas futures, you can be, if you have the gas futures that is for only a kind of low congestion environment, then you won't be able to use them in a high congestion environment. And so therefore there's not as much of this kind of, filling up state just to retrieve it later on. Yeah.
Got it. Thank you.
Okay, so, right. Okay, so the third point, improve the security for state channels, plasma, optionals, and other fraud-proof driven solutions. Having the base fee as an input allows you to lengthen the challenge period automatically if you see that the base fee is high. So this is pretty self-explanatory if you know what it's talking about. So what it's talking about is that there are these off-chain kind of scalability solutions, and what they require is ultimately you commit something to a more secure, less scalable base layer like Ethereum mainnet. But there's an opportunity there for one party to defraud the other, and therefore there needs to be a challenge period for fraud proofs to be given. If contracts have visibility into the base fee and therefore the network congestion, they can lengthen that challenge period if the base fee is high, so that the kind of security guarantees or security properties of this challenge period respond dynamically to that, and are more in line with perhaps time as opposed to block time in like the blockchain space, time in the real world. So those are the motivations, and the specification is quite easy. You take when you call base fee, it's a very low cost transaction, and you just push one item onto the stack, which is the block base fee, and then whatever opcodes come after that can manipulate that. That's pretty much it.
So I just want to kind of, I guess, clarify one thing.
Yeah.
Basically, the gas fee, this EIP wouldn't change anything about the gas fee or the way that Ethereum works. If I'm understanding correctly, it wouldn't change anything. All it would do is make it more easily accessible, basically.
Yeah. So it doesn't change how, for example, users will not. It does not change how users specify their fees on any more than 1559 does. That's all the same. What it allows is these different patterns of contracts, because we might as well make the base fee observable. So it does kind of it changes the space of possible contracts that you can create by making this observable.
It seems a little bit like how do contracts do it now, or how, or can they just not? Is it like determined after the block is mined?
Yeah, I don't. As far as I can tell, there's no way to tell in your during your transaction execution how congested Ethereum is or anything like that. You are just executing, and you could be executing in a block that is nearly empty. You could be executing in a block that's really full. You have no idea. So that's why this introduces kind of a bigger design space.
I mean, so I definitely understand like the application of it, and that makes total sense. But like I know when I'm submitting a transaction, say on Metamask or whatever, it gives me an estimate for how much the gas will be, or how much the cost of my transaction will be. And so I'm curious like how it's done right now, where can you kind of like derive the gas fee? Is it available on the block? Is it like, because I understand that the opcode itself is like a much more readily available and executable like way of handling the gas fee, but I'm just wondering like how it changes things.
Yeah, sure. So the specific question is about, or like the motivating kind of example is you're creating a transaction and your wallet is providing you a suggested gas price, right? You're wondering how that suggested gas price gets there. Right. So the way that gets there is actually one of the motivations why 1559 was created, which is that what these wallets are doing is looking at recent history of the recent blocks and seeing how much people are paying in order to get included. And then there are these complicated estimation algorithms that they're using on top of that in order to estimate it. But these estimation algorithms are not so efficient. They can often cause people to overpay, and that's one of the reasons why 1559 introduced this base fee as kind of like a in protocol way to suggest to users, okay, this is about what you ought to be paying in order to get into the block now or within like 1 or 2 blocks. Yeah, it was completely implementation. Yeah.
So then I guess my question would be, is the primary change that you're able to see now the price of your transaction before you make the transaction, and currently, like before this is implemented, you can only tell the price of your transaction after the transaction. Is that do you think that that's accurate?
So I think this is kind of straying more into 1559 territory, where kind of the base fee opcode assumes the existence of 1559. So if we're talking about what 3198 does, is that from the user's perspective of submitting a transaction, if you didn't implement 3198, it wouldn't be any different, right? So you as a user, if we didn't implement the base fee opcode, would still have the benefit that 1559 gives of this, easily of this base fee that you can observe and submit the transaction because you're outside of the protocol. But if you wanted to observe it within the protocol, you would need the base fee opcode.
So then, does the I guess currently on mainnet, does the base fee exist?
No,
like not
so
this.
Yeah.
Okay.
So there's not even a concept of base fee right now on mainnet. So that's why it requires 1559. 1559 will introduce the base fee, and then this will make sense. Like this wouldn't do anything today.
That makes total sense. Okay, yeah, that makes sense. All right. No, I think I'm good. Thank you.
Cool.
One way that I've explained 3198 is that it brings an oracle native to the protocol, whereas most oracle systems are outside and operated by people external to the protocol. This just makes it a native element. Sorry.
No worries. Yeah.
Great. Thanks.
It's a very, very specific kind of oracle. Yeah.
Yeah, I have kind of a bit of an unrelated question, but what do you mean by mint gas token? Is that, are you providing Ether to buy that, or yeah, what does that mean?
Yeah, so when you mint a gas token, so what that means is, so how gas tokens work is there's a gas token contract out there. And when you mint something, what you're doing is you are just storing a bunch of state in that contract. And when you store a bunch of state in that contract, the contract will mark that you own a gas token. And a gas token corresponds to like a certain, maybe hundreds or, thousands maybe of like slots of storage. So now you get this gas token. Then you minted that when, prices were low. And then when you spend it, you basically send it to the contract. The contract frees those slots. You get a refund, so it subsidizes whatever transaction you're doing in the moment, and that gas token gets destroyed then. So it's essentially a way you're using this, the contract that is the gas token contract is kind of like a bank or a battery to store state, get tokens, or destroy tokens and release the state.
But you use Ether to mint those with, right? What happens to the Ether, right? You use Ether to create a mint token?
Yeah, so you use the Ether to essentially store all of because you're paying a good amount of gas in order to store essentially these arbitrary values in the storage. So that's the main form in which you pay. You pay Ether now in order to store store random values into the storage, and then just like a small amount in order to do the bookkeeping in the gas token contract. But it's not like the minting isn't like a trade necessarily. It's not like you're sending Ether to the contract that then it gives you a token back.
So I have a question related to the point number 3 mentioned in the motivation section. It says that improve the security of stake, channel, plasma, optrails, and other fraud-driven systems. So if I understand, that's a kind of help to mitigate the attempt of DOS attack by strengthening the challenge period. So what is this delayed challenge period or challenge period?
Right. So I was talking earlier about how because these kind of off-chain, these specific off-chain scalability solutions require a commitment to the to the less scalable, more secure base layer. This is a moment where someone can attempt to send this or attempt to submit a fraudulent state of affairs of what that kind of, for example, that state channel, what that what was the state of that. And so in order to mitigate that, you need to have a period in which it is not yet valid, and it gives anyone an opportunity to submit a proof that shows that this actually could not be the state that an honest actor would attempt to commit. And because you need enough time to do that, it's worth it to change the challenge period according to network congestion.
That's interesting. Moving on to the security consideration, there are some people who are concerned with making gas prices accessible to the EVM, believing it may impose some risks that can cost future gas cost changed in the future. So I'm curious to understand the difference between the base fee and the gas observability.
Yeah, I actually can't remember what the gas price current opcode returns in the case of a 1559 transaction. In the case of a normal transaction, the gas price, so that the gas price opcode was the existing kind of observability of how much a person ended up paying for, or how much a transaction ended up paying when it was included. And yeah.
So what I'm trying to understand here is while implementing this in your client Besu, did you find any kind of edge cases that suggest this actually happens and that is actually a security concern if we allow opcodes to be accessible by EVM?
No, for security concerns. What making things observable to the EVM, what the drawbacks of making things observable to the EVM are, is that they become dependent on for the execution of certain transactions, and then it can potentially be more of a headache later on when we want to deprecate things or change how things work or something like that. So it's not a security consideration, and there's obviously no plans to deprecate base. We haven't yet implemented it, but it's conceivable that in the future this opcode maybe wouldn't make sense in a certain context, and therefore its behavior changes. And we've seen over and over many instances where an opcode is, we kind of have to step around and understand how a change that we propose would change the behavior of an opcode, what contracts that would break, etc. So I wouldn't consider it a security problem as much as just another thing to depend on, a potential a protocol design issue somewhere down the line.
Right. Okay, if I may go a little off to the proposal 1559.
Sure.
First of all, congratulations for merging 3198 in Besu. I heard that Elute, the testnet for London, is up now. So
yeah, Abdel really deserves all the praise for the engineering work on 1559. Of course, Tim did so much of or was the main driver of the project stuff, but yeah, Abdel implemented 1559 and base fee, yeah.
Yeah. So yeah, I mean, for people who don't know, we were hoping to have Abdel here, but going on some leave, so we could not have him. But thank you for joining, Rai.
No worries.
I have a small question related to that, like this misconception of burning ETH with 1559. So as I understand, this is basically the base fee that will be burnt, right? Why burning base fee?
Well, there's a couple of things. One, it makes sure that it kind of enshrines Ether as the way to pay Ethereum in order to execute your transactions. So the Ethereum protocol, if it requires a base fee, means that you can't get around requiring Ether to be included into the blockchain. And because one way to think about it is, don't think about it as burning, but think of it as paying the Ethereum protocol, and then the Ethereum protocol never pays anyone else back. That's kind of how you can conceptualize burning. And it's important that it's burned and not given to the miners, because if it's given to the miners, then they can coordinate in order to artificially reduce the base fee and therefore capture more of the fees for themselves.
That is very interesting. Thank you so much for that. Well, this was really great. Thank you, Rai, for joining us today and talking about the proposal. I think this is one of the fastest moving proposal towards inclusion and standardization. As you mentioned that it's a lot of work being done by Tim Baiko and Abdel Hamid. So many congratulations to author and of course the client team implementers for this great work and coordination. To me, it seems like it has a lot of useful features for also upcoming projects like optimistic rollups and others. So I hope to see this proposal on the mainnet with EIP-1559 in summer this year. Best wishes for Elliot DevNet.
Thanks, Pooja.
On this note, for our YouTube viewers, thanks for watching. We did an episode on EIP-1559 with Tim Baiko. So if you have missed watching the overview of EIP-1559, that is the fee market change, you may follow the recording at PEEPanEIP YouTube at Ethereum Cat Holders. Ethereum blockchain is expecting multiple upgrades in 2021. The first one is expected on April 15th, and Ethereum Cat Holders are organizing a community call inviting everyone to join us to follow the upgrade with Ethereum developers, the EIP authors whose proposals are going in, editors, and other community members. The details are provided in the description section. As always, we'd love to hear feedback and improvement suggestions. Do let us know which EIP would you like to see in future episodes. If you like this episode, hit like and share. We have many more interesting proposals coming up for London as well. So stay tuned, keep watching, and keep sharing your love with Ethereum Cat Holders. This is all of us signing out.